Hello everyone, this is John Hashbut and welcome to Physics Simply. In this video I will be solving the paper 2 exam for May-June 2021 variant 1. So let's get started. Question 1 says a diagram shows a stone of irregular shape. Which property of the stone can be found by lowering it into a measuring cylinder half filled with water? It's not the length, mass, it is the volume, not the weight. So the answer is C. Question 2 says which row describes speed and velocity? Speed is a scalar quantity, velocity is a vector quantity, so the answer is B. Question 3 says 4 balls with different masses are dropped from the heights shown. Air resistance may be ignored. Which ball has the smallest average speed? So we can say that falling under gravity is a constant acceleration type of motion, so we can use that the average speed is equal to the total distance divided by the total time, and we can also calculate it by using v plus u over 2, the average of the initial and final velocities, and they all started from rest. So the one with the smallest final velocity will have the smallest average speed, which means that the one that didn't take much time falling, which is with the smallest distance, has the smallest average speed, so the answer is A. Question 4 says an object of mass 2 kilograms is taken from the Earth, where the gravitational field strength is 10 newtons per kilogram, to the Moon, where the gravitational field strength is 1.6 newton per kilogram. Which row is correct? The weight on Earth is equal to 2 multiplied by 10, and the weight on the Moon is equal to 2 multiplied by 1.6. So 2 times 10 is 20, and 2 by 6 is equal to 3.2. So the answer is D. Question 5 says the mass of an empty flask is 34 grams. The volume of liquid added to the flask is 20 centimeter cubed. The total mass of the flask and the liquid is 50 grams. What is the density of the liquid? So we need the mass of the liquid by subtracting 50 minus 34 divided by the volume, which is 20 centimeter cubed. We get then an answer of 0.8 grams per centimeter cubed. So the answer is A. Question 6 says the extension load graph for a spring is shown. The unstretched length of the spring is 17.0 centimeters. When an object is suspended from the spring, the length of the spring is 19.2 centimeters. What is the weight of the object? So we have the new length and the original length. We can calculate the extension, 19.2 minus 17.0. That gives an answer of 2.2 centimeters. So we can use that from the y-axis, the extension axis, to get the force from the x-axis. From the graph here, we have 3 newtons, so the answer is D. Question 7 says a cart has a mass of 10 kilograms. A boy pushes on the cart horizontally with a force of 50 newtons. The cart accelerates at 0.50 meters per second squared. What is the frictional force acting on the cart? So we have an object with a forward force of 50 newtons and an opposing force unknown. We can use the equation F is equal to ma, but F is equal to the resultant of these two forces. So 50 minus F is equal to the mass, 10 kilogram multiplied by the acceleration, 0.50. So we can replace these here. 10 times 0.50 is 5, so we calculate 50 minus 5, that's 45 newtons. So the answer is D. Question 8 says a ball has a mass of 2 kilograms. The ball approaches a wall at a speed of 3 meters per second and rebounds at a speed of 1 meter per second. What is the impulse on the wall? So the impulse is equal to the change in momentum. We have the mass 2 multiplied by the change in velocity. So we have the final velocity 1 and the initial velocity is negative 3. We took the direction to the right positive and to the left negative. You are free to choose whatever, but I chose it this way. So we have 2 multiplied by 4. So the answer here is 8 newtons. So the answer is C, not newtons second, it's newtons. Question 9 says which situation involves no work being done and no energy being transferred? A car skidding to stop on a road. So there must be friction or frictional force and there is a distance, so there is work done. A crane lifting a load, again there must be an upward force to lift something. A heavy load hanging from a strong bar. Hanging means there is no distance. So this means there is no work, so the answer is C. Question 10 says a student suggests that there are several ways to transferring energy to a small stationary block of iron on a smooth table. He makes the following suggestions. Heat it, that will transfer energy. Shine light on it, that will heat it again. Pass a current through it, that will also give it energy. So all sentences are correct, so the answer is D. Question 11 says an engine produces 240 kilojoules of energy in 2 minutes. What is the power output of the engine? So power is equal to energy divided by time, or work divided by time. So we have 240,000 for kilo divided by 2 minutes. That's 2 times 60. That gives an answer of 2000 watts. So the answer is 2 kilowatts, and the choice is A. Question 12 says a book has a mass of 400 grams. The surface of the book in contact with the table has dimensions 0.10 meters by 0.20 meters. The gravitation field strength G is 10 newtons per kilogram. What is the pressure exerted on the table due to the book? So the pressure is equal to the force divided by the area, and the force in this case is the weight of the book, and then we divide that by the area. And to calculate the weight, we need to convert from grams into kilograms. That's dividing by 1000, so 0.400 instead of 400, times G, 10 in this case, over the area 0.10 multiplied by 0.20. That gives an answer of 200 pascals, or 200 newtons per meter squared, so the answer is D. Question 13 is about barometers, so you can skip this question for the new syllabus. It says the diagram shows a mercury barometer, at which point is the pressure greater than the atmospheric pressure. So A is actually 0 Pascal, B is less than the atmospheric because we have less depth of liquid. At C it is equal to the atmospheric pressure, and any more depth below that causes the pressure to be greater than the atmospheric, so the answer is D. Question 14 says the table gives information about molecules. Which row describes a gas? The force between molecules in a gas is negligible or weak. The distance between molecules in a gas is far apart, so the answer is C. Question 15 says very small pollen grains are suspended in water. A bright light shines from the side. When looked at through a microscope, small specks of light are seen to be moving in a random jerky manner. What are the moving specks of light? It's pollen grains, not water molecules. You cannot see water molecules using this microscope. Being hit by other pollen grains? No. By water molecules? Yes. So the answer is B. Question 16 says, why are small gaps left between the metal rails of a railway track? To allow for expansion of the rails on a hot day, to allow for contraction. No, it's for expansion, but not on a cold day. It's for a hot day, so the answer is A. Question 17 says a block of metal absorbs 2000 joules of thermal energy. The temperature of the block rises from 10 to 20 degrees. That's plus 10 degrees Celsius. The mass of the block is 2 kilograms. What is the specific heat capacity of the metal? So the specific heat capacity is equal to the energy divided by the mass and the change in temperature. So we divide 2000 by the mass, checking for the units here, kilograms. So we keep the mass in kilograms, 2 kilograms, and then multiplied by the change in temperature, 10 degrees. So we get an answer of 100 joules per kilogram degrees Celsius. So the answer is B. Question 18 says which statement about boiling and evaporation is correct? Boiling requires a supply of thermal energy, but evaporation does not. This is kind of tricky because evaporation requires energy, but not from a power supply, from an external supply. It can take energy from the neighboring molecules, so we will leave that on the side. Evaporation takes place at the surface of the liquid, but boiling takes place through the liquid. That's 100% true, so the answer is B. For choice C, it says when water boils in a kettle, its temperature decreases. No, its temperature is constant. When water evaporates, its temperature increases. It decreases because evaporation causes a cooling effect. Question 19 says a metal rod is heated at end X. Why does end Y of the metal rod become hot? Energy is transferred from end X of the rod to end Y by vibration of positive ions and by movement of electrons. Yes, energy is transferred from end X to end Y by movement of positive ions, not movement of ions. Energy is transferred from X to Y by vibration of positive ions only, not in metals. In metals, there are free electrons. Energy is transferred from X to Y by moving of electrons only, not only, also by vibrations and collisions between neighboring molecules. So the answer is A. Question 20 says two square sheets of metal P and Q are heated to the same temperature. The metal sheets are shown. Sheet Q is emitting more radiation than sheet P. Which statement explains this? Dull black surfaces are better conductors of radiation. There is nothing called conductors of radiation. Dull black surfaces are better emitters of radiation. Yes, but the sheet that is emitting more heat is actually Q. So this is a correct sentence, but not related to this question. Question C says the surface area of Q is larger than P. That would cause more heat to be radiated. White surfaces are better absorbers. We're not talking about absorption, so the answer is C. Question 21 says a water wave passes into a region where the wave travels more slowly. As it passes into the slow region, what happens to the frequency and what happens to the wavelength of the wave? So the frequency always remains the same in refraction, diffraction, or reflection. The wavelength is dependent on the speed, so the speed decreases because it says more slowly, so the wavelength also decreases, so the answer is C. Question 22 says light traveling at speed 3 times 10 to the power of 8 meters per second strikes the surface of a glass block and undergoes refraction as it enters the block. The diagram shows a ray of this light before and after it enters the block. What is the speed of light in the glass? So we can use the refractive index is equal to the speed in air divided by the speed in the medium and is equal to sine the angle in air divided by sine the angle in the medium. And you can use this section of the equation. So 3 times 10 to the power of 8 in air divided by the unknown speed in the block is equal to sine the angle 55 in air divided by sine 33 the angle in the medium. So we do cross multiplication. We multiply 3 times 10 to the power of 8 by sine 33, then divide by sine 55. That gives an answer of 199,464,000 approximately. So the answer is approximately 2 times 10 to the power of 8. So the answer is B. Question 23 says the diagram shows a narrow beam of light incident on a glass-air boundary. Some of the light emerges along the surface of the glass and some is reflected back into the glass. Which row is correct? This is an example of total internal reflection. No, because part of the light was refracted and the rest was reflected. Is the angle theta the critical angle? Yes, because it has an angle of refraction 90 degrees. So yes and yes. So the answer is A. Question 24 says an object is placed in front of a thin converging lens. The diagram shows the path of two rays from the top of the object. An image of the object is formed on a screen to the right of the lens. How does this image compare to the object? So if we continue the rays so that they intersect like this, we will find that they will intersect approximately at this point. So the image will be inverted since the top of the image created a bottom of an image here, and the tail is still on the principal axis, and the size of the image is larger than the object. So it is larger than the object and inverted, yes, not same way up. So the answer is A. Question 25 says a remote controlled vehicle is traveling on the surface of a planet. The vehicle senses an obstacle ahead. It sends a radio message to the control room from where it is being controlled. The control room is 2.4 times 10 to the power of 6 kilometers away from the vehicle. The control room sends a message back to the vehicle telling it to stop. What is the minimum time that elapses between the vehicle sensing the obstacle and receiving the message back from the control room? So that's going two ways. So we say that the speed is equal to twice the distance divided by the time. So the time is equal to twice the distance divided by the speed. So we have 2 times 2.4 times 10 to the power of 6, but that's in kilometers, so we multiply by 1000. Then we divide by the speed of light because it's a radio wave. It travels with the speed of light, which is 3 times 10 to the power of 8 meters per second. That gives an answer of 16 seconds, so we choose D. Question 26 says a sound wave is traveling outwards from a loudspeaker into the surrounding air. Here are the 3 statements. One says the air pressure is lower at a rarefaction compared with undisturbed air. Yes. The density of the air is less at a compression. No, it should be more because there are more molecules close to each other. The distance from a compression to a rarefaction equals half a wavelength. Yes, because from a compression to the next compression is one wavelength and the rarefaction is in the middle. So sentences 1 and 3 are correct. So the answer is B. Question 27 says a sound from a loudspeaker must pass through 2 materials to reach a microphone. Which combination of materials give the shortest time for the sound to reach the microphone? So shortest time means greatest speed, and sound travels with the greatest speed in solids. So we choose solids. Here we have copper and here we have aluminium solids. So the answer is C. Question 28 says diagram 1 shows a small compass needle with its poles marked. It is not near any magnetic materials. Diagram 2 shows a bar magnet with its poles marked. The compass needle is placed at point P. In which direction will the N pole of the compass needle point? So if we draw the magnetic field line from the N pole to the S pole, it should be pointing this way. So the North Pole will point in the same direction because the N pole is always in the same direction of the field. So here it is pointing to the right, so the answer is B. Question 29 says a student rubs a plastic rod with a cloth. The rod becomes positively charged. What has happened to the rod? Becoming positively charged means there is a loss of electrons, so protons cannot move. Lost electrons, yes, so the answer is C. Question 30 says an isolated metal sphere is positively charged. It is then brought near to another isolated metal sphere that is neutral. What happens to the charges on the neutral sphere as the positively charged sphere is brought close to it? So positive charges move, no, positive charges move, positive charges move. Positive charges do not move, but some negative charges move to the left, attracted to the positive charge, yes. So the answer is D. Question 31 says which statement about the resistance of a metal wire is correct? The resistance is directly proportional to its length, yes, proportional to the length, not inversely proportional, and directly proportional to its cross-section area, not directly, it is inversely proportional to the area, so the answer is B. Question 32 says the circuit diagram shows a light-dependent resistor in a potential divider. A voltmeter is connected across the LDR. Which row shows the resistance of the LDR and the potential difference shown on the voltmeter at a specific light level? So for bright light, the resistance of the LDR is low, yes, high, no, dim light, high, yes, dim light, low, no. So B and D are rejected. And for the voltmeter connected in parallel with the LDR, when the resistance is high, the voltage is high. So low and high is not correct, high and high is correct, so the answer is C. Question 33 is about logic gates, so you can skip this for the new syllabus. It says 3 NAND gates are connected in a single chip as shown. The whole chip behaves as a single logic gate. Which type of logic gate does the chip act as? So we need to try the inputs and the outputs. So if both inputs are 0, this is typically a NOT gate. So it reverses the input, giving us 1 and 1 here. 1 and 1 to a NAND gate that gives 0. Now if the inputs are 0 and 1, so we have 1 coming out of the top one and 0 from the bottom one. 1 and 0 from an AND gate that gives an output 1. If we reverse the inputs 1 and 0, that's 0 at the top and 1 on the bottom and 1 from the output. And finally, if we have 1 and 1, that's 0 and 0, and that gives an output of 1. So 0, 1, 1, 1. So 0, 1, 1, 1, only 0 when both inputs are 0. That's an OR gate. So the answer is D. Question 34 says a solenoid is connected to a very sensitive ammeter. A rod is inserted into one end of the solenoid. The ammeter shows that there is a small electric current in the solenoid while the rod is moving. That's electromagnetic induction. Which rod is being inserted? Not a heated copper rod. A magnetized steel rod, yes, because we need a magnetic field being cut or there is a change in flux in the coil to induce a current. So the answer is B. Question 35 says the diagram shows an electric generator with the coil in a vertical position. Which row describes the generator? It generates AC, not DC, and the voltage output will be 0 when it is vertical, not horizontal. So the answer is B. Question 36 says the diagram shows a transformer. There are 460 turns on the primary coil and 24 turns on the secondary coil. The primary voltage is 230 volts. What is the secondary voltage? We can use Vs over Vp is equal to Ns over Np. And substituting, we have Vs, the unknown, divided by 230, the primary voltage. And we have 24 turns on the secondary and 460 turns on the primary. Now we do cross multiplication, 230 by 24, then we divide by 460. That gives an answer of 12 volts. So the answer is B. Question 37 says the charge on a proton is E. What is the charge on an electron and a neutron? So an electron has a charge of negative E, equal in magnitude but opposite in polarity. And the neutron is neutral, so 0 charge. So the answer is D. Question 38 says 4 students are asked to comment on the process of nuclear fission and nuclear fusion. Their comments are recorded in the table. Which row is correct? Energy is absorbed? No. A large unstable nucleus splits in fission? Yes. 2 light nuclei join? No. Energy is released? Yes. For fusion, a large unstable nucleus splits? No. Energy is absorbed? No. Absorbed? No. 2 nuclei join together? Yes. So the answer is D. Question 39 says radon 219 and 86 decays by emitting an alpha particle. Which nuclide is formed in this decay? So for an alpha particle, the nucleon number decreases by 4. So 219 minus 4 is equal to 215. And the proton number decreases by 2. So it will be 84. So the answer is A. Question 40 says the graph shows the activity of a radioactive source over a period of time. What is the half-life of the source? Since there was no mention of background, we use the initial value and we divide it by 2. We get 60. For half-life, we go to the graph line to find the time on the x-axis. So the time is 2 minutes and the answer is B. This was the end of the exam. I hope you enjoyed this video and found it useful to you. Keep practicing and I will see you in another video.